Hi everyone, this is Chitra from Department of CSE AI. I'm here to explain about the topic called corrosion. Here are some few topics to be covered under the corrosion. Firstly, introduction to corrosion. Corrosion is deterioration and loss of material and its critical properties due to chemical, electrochemical and other reactions of exposed material surface with the surrounding environment. Example like formation of rust on iron, tarnish on silver and blue-green patina that develops on copper. Here are some few snapshots of corrosion. Occurrence of corrosion. How do corrosion occur? Corrosion may occur either in dry environment or in aqueous medium. The former is called dry corrosion and later is wet corrosion. Firstly, dry corrosion. The dry corrosion occurs in the absence of moisture or conducting electrolyte medium due to direct attack of metals by dry gases, mainly through chemical reactions. Example like the attack of dry gases such as O2, halogen, H2S, SO2, etc. on a metal to form an oxide layer over the surface. Second one is wet corrosion. Wet corrosion involves reaction in aqueous medium. The conducting surface of metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. Example like rusting of iron. Wet corrosion can be better explained on the basis of electrochemical theory. Here are some types of corrosion. First one is differential metal corrosion and second one is differential aeration corrosion. Firstly, differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each other and exposed to corrosive conducting medium. The metal with lower electropotential acts as anode, undergoes oxidation and gets corroded, and the other metal with higher electrode potential acts as cathode, undergo reduction and protected from corrosion. This type of corrosion is known as galvanic corrosion or differential metal corrosion. The reaction may be represented as at anode, metal gives rise to metal plus electrode. At cathode, reduction takes place depending upon the nature of environment. 2H plus 2 electron gives rise to H2 or 2H2 plus O2 plus 4 electron gives rise to 4OH minus. And this is second type of corrosion, differential aeration corrosion. When metal is exposed to differential concentration of air or oxygen, part of metal exposed to over concentration of oxygen becomes anodic and undergoes corrosion, whereas other part of metal exposed to higher concentration of oxygen becomes cathodic and remains unaffected. These kind of corrosion is called as differential aeration corrosion. The anodic and cathodic reactions are at anode Fe gives rise to Fe2 plus electrons. At cathode 2H2O plus O2 plus 4 electron gives rise to 4OH minus. The overall net cell reaction is Fe2 plus 2OH minus gives rise to FeOH twice. Under differential aeration corrosion, we have two types of corrosion. One is waterline corrosion and second one is pitting corrosion. Firstly, waterline corrosion. It is observed in steel or iron water tanks partially filled with water. A distinct brown line is formed just below the waterline due to the deposition of rust. The cell reaction are followed at cathode and anode. At anode, metal gives rise to metal plus N electrons. At cathode, 2H2O plus O2 plus 4 electron gives rise to 4OH minus. Finally, the ions combine to form corrosion product. Example like ships which remain partially immersed in seawater for a long time undergo this type of corrosion called waterline corrosion. Second one is pitting corrosion. This type of corrosion is observed when dust particles or oil drops deposited over the metal surface. Pitting corrosion is due to first one is metal surface is not homogeneous, second one is external environment is not homogeneous, third one is crystallography directions are not equally in reactivity. Environments are uniform with respect to concentration. Once a small pit is formed, the rate of corrosion increases because formation of small anodic area pit to corrode faster because accepting electrons from cathodic area increases. The cell reactions are at anode Fe gives rise to Fe2 plus 2 electrons. At cathode O42 plus H2O plus 2 electrons give rise to 2OH minus. Net reaction Fe2 plus 2OH minus gives rise to FeOH twice. And the last topic we are going to learn under corrosion is corrosion control methods. How do we control corrosion? Here are some few methods followed. Corrosion can be controlled by preventing the formation of galvanic cells on the surface of metals. The methods to control corrosion can be classified as: first one is design and selection of metals, second one is protective coating, third one is cathodic protection. Under protective coatings we have two types: inorganic coatings and second one is metallic coatings. We are going to briefly run about protective coating now. Corrosion is prevented by the application of protective coating on the surface of metal, thereby the metal surface is isolated from the corrosive environment. Important types of protective coating are metal and inorganic coatings. Second one is cathodic protection. Cathodic protection is technique of offering protection to a specimen against corrosion by providing electrons from an external source. There are two important methods of cathodic protection. First one is sacrificial anode method and second one is impressed current or voltage methods. Thank you.